I am going to talk about advantages and limitations, both of some of the past models and the current model that we're using at the Mesonet. And of course, all this is really about the animals, trying to find that spot where they can do best, and we can begin to minimize some of the stress that they're going through. My background, I've got a bachelor's from Oregon State University and a master's from Ohio State University. And I am a certified crop advisor and certified professional horticulturalist, which may have you wondering what's going on. Why am I working in weather? And part of that is that I've worked for Oklahoma State University in extension since 1989, but I have worked as the Oklahoma Mesonet Ag Coordinator since 2002. So it's really in that role that I deal with things like the Cattle Comfort Advisor, cattle stress. I'm officed at the National Weather Center, which is unique because the vast majority of people in this building are weather folks, meteorologists by training. There's a few climatologists, and then myself that's at this facility down in Norman. The Oklahoma Mesonet, if you're not familiar with it, we have 120 stations across the state, and so we have really good coverage. Data comes in off that system every 5 minutes, which allows us to do some unique things in terms of really getting a statewide view of what's going on. So what we're going to talk about today is really environmental stress, both from the heat aspect and from the cold. And cattle are amazingly adaptable and really function very well through a wide variety of conditions. What we want to try and look at, though, is some tools that can help us really pick up when those conditions turn into something that would really hurt their health, hurt gain for the cattle producer, and put the animals in jeopardy. And in the past, we used to talk about stress. So why comfort, not stress? Well, we really want to try and emphasize that we're trying to keep those animals in that comfortable range. And that changes as we move through the season. So it's not a set range. As that hair develops as we move into the winter, the cattle are very adaptable to much colder conditions. And likewise, as they lose that hair and move into the summer, they can take some heat. But we're really trying to emphasize trying to keep them in that comfort zone for their own health. And I love this picture. It just is an excellent reminder that the animals are going to move to where they are comfortable. So here you've got this huge giant field, some pretty good decent grass, and in the heat of the day, those cows are just absolutely huddled under the shade of a large highway sign, trying to keep cool and avoid that heat. So when we start looking at environmental cattle stress or cattle comfort, what weather variables really impact the animals? And what we're really looking at is air temperature, and then we're looking at adjustments on that air temperature from solar radiation, relative humidity, and wind speed. And it really makes a difference what season we're at and how those are going to impact the animal. So in the winter, when we look at a temperature adjustment, a plus is sunlight to that air temperature. The minuses for us in the winter would be wind speed and relative humidity. They're going to add to the cold stress the animal is under. In the summer, Wind speed becomes a plus for us. Now sunlight moves to the minus category because it's adding heat load, and relative humidity is still a minus, whether we're in summer or winter. And we need to be aware that the environmental impact really varies with the animal. So size makes a difference, health makes a difference, recent transport, if they've moved from one location to another, makes a difference, their breed makes a difference, and their hair coat color. So we have all of these different factors, and it's really important if you're looking at numbers and those kind of values to really compare how those relate to the animals that are in your local area, and then what those animals are actually stressed with in terms of what they deal with. In the past, on wind chill, one of the things that we looked at was hair coat, and so we would take a look at how that hair coat changed as we moved from a summer condition into a winter condition. One of the things to note when we get to that hair coat is that if the animal gets wet, sorry about that, if the animal gets wet, then that summer, all of that insulation that is on that winter coat really goes back to a summer type condition. So that's a situation where a wet storm can really cause some troubles. And I think up in the north, we just had a very wet storm come through. They were talking in the neighborhood of 1 inch of water per 6 inches of snow, which is a very, very wet snow. The other thing in terms of stress is we really have to think about where those animals are. Are they in a feedlot situation? Are they out in a pasture type setting? It's going to make a big difference about the kinds of things we need to pay attention to. For instance, in a feedlot situation, heat stress can come on much quicker because we have so many animals in a smaller area. Out on a range type setting, we might be more concerned about cold situations, blowing snow and those kind of things. The other thing is, depending on our situation, if we're in a feedlot situation, we may have more management that we can do in terms of feeding times, in terms of turning on misters or building shade. That may not be as easy in a pasture setting. So we may not have in a pasture setting as many management things as we can do. And the other thing is that a good cattle producer is going to pay attention to their animals. So when we start looking at taking models and putting numbers to situations, what we're really doing is we're taking that good judgment that a good cattle producer has, and we're putting values to that so that we can record that data, and then we can repeat that. It will also give us a chance to really pick up those extremes a little bit more, and we'll look at some products that do that. But the animals really, through their behavior, tell you very quickly, are they heat stressed? Are they comfortable? Are they trying to change their body temperature and get that back to a more equal spot? These animals were all laying down trying to avoid wind. So that wind was coming out of the north, and most of these animals had their tail ends pointed in that direction and head away from the wind direction. And then when everything's right, you can drive by and see animals just out there grazing and really enjoying their setting and making the most of whatever pasture they have. If we take a look at traditional cattle stress models, we really had two. We had a cold stress model, which ran in the winter season. That was air temperature and wind speed. And then we had heat stress models that ran in the summer, and that included air temp and relative humidity. And when you think of the current human models for cold stress or wind chill, heat stress or heat index, those are still commonly used. If we look at those traditional stress indexes, the summer index, that air temperature was adjusted by relative humidity, and then as we mentioned, air temp adjusted by wind in the winter. What was missing was the impact of solar radiation and the relative humidity in the winter, and then wind in the summer. So we've really have an opportunity now with a new model to look at adding those in. And most importantly for the Great Plains, we missed spring and fall transition times. And I'll show you a map here in just a little bit that really picks that up. And we see big swings in the Great Plains. And so having something that doesn't miss those transition times is really helpful. And one of the products that is still using some of those traditional type models is the thermal aid. It is out of Missouri, and it takes the weather and puts that into a respiration and tips for how to deal with that. And certainly not a bad tool. It's just not using all of the things that we could use, but it's certainly better than nothing, and is something that folks can easily take with them. And we don't have a lot of tools for a cell phone. One of the other products that's out there, this one happens to be from the USDA, and I apologize for the long URL. You can find that by just putting in ARS or USDA and typing in on a search engine, the cattle heat stress, and that will take you to this page. But one of the things about this is that they are using air temperature, relative humidity, wind speed, and cloud cover. Cloud cover would be an estimation of solar radiation to come up with heat stress forecasts for the nation. So this is a new product that's been out and is really a nice tool for going nationwide with these forecasts. And you can see here, this is a forecast for Friday, November 20th of last week. And you can see that there was some heat situations and probably high humidities coming into that Florida area. Rest of the area was normal as they looked across the U.S. The Oklahoma Mesonet, one of the things we were able to do was work with Terry Mader and used a new stress index that he came up with Dr. Goggin and L.J. Johnson. And this index has some really nice advantages. It's a jump ahead of the older traditional stress indexes. Terry Mader is no longer with the University of Nebraska. He is now has a consulting firm that he does. But I like this quote from this particular article that was he was quoted in. Weather has been more variable in recent years, and heat stress levels have increased about 1% each year since 2000. And so I know for Oklahoma and the southern Great Plains, we really do worry a lot about heat stress, not so much about cold in terms of animal fatalities. We might worry about it in terms of health of the animals. And then J.B. Goggin, John Goggin was the other professor that worked on this particular formula and model, and this is his contact information. And both he and Terry Mader, Dr. Mader, are both active with stress on livestock and how to get around that. The advantages of the model that they came up with is that it runs year-round. It includes all the key weather variables that I talked about earlier, and it does those year-round, which is really important. It combines hot and cold stress into one model, so we don't we can actually see, and we'll see that in just a minute, but we can actually see hot and cold stress in our state, in Oklahoma, on the same day at the same time. And the model was set up so that it can be used for multiple species once you begin to tie the impact on that species with the index that's there. This was a map from October 25th, 2012, actually at 10:15 in the morning, and it really depicts how wide a conditions we can have across the state of Oklahoma. And I think you can probably see this in other Great Plains states. But you look down in the southeast, you see cattle comfort conditions where there's actually a little bit of a heat stress situation, 79 degrees. And then you move across most of the state, and we go from the 60s and down into the 30s. And as we get up into the panhandle, you can see way out west, there's a 19. So huge range, all this at one 5-minute point in time across our state. And that's one of the nice things about the Mesonet is that because all of the data comes in at exactly the same time, we get a full picture across the whole state. And these are just a listing of the measurements that we take. So air temp and rainfall, relative humidity. You can see solar radiation in there, and then down at the bottom, wind speed, which are the important things that we've been looking at for this cattle comfort, cattle stress model. We have an agriculture section through our main website, so we can go there, and then we have a livestock section, and we have cattle, dairy, poultry, and swine, and from there we can drill down into the Cattle Comfort Advisor. This is just a map looking ahead through November 26th. And again, it gives you an indication of the kind of range that we can have across the state. So this is going to be where a cold front is moving through the state, and we range from 51 down in the southeast up to 9. And depending on how fast that cold comes through, it can really have an impact on the health of the animals and their susceptibility to infections. When we start looking at the heat index side of things, one of the things that I've found is that, every day is hot, it's hot in the summer, and you don't really pay a super amount of attention sometimes to some of the individual things. But right in here, down in the southeast, you can see that the numbers were up to 121, which is incredibly stressful on the animals. And you can see a local area above that. Here's 119, not far away, 114. So what putting numbers on things allows us to do is really pick up some of those points in time where things, the wind dies down, the humidities are high, the temperature's high, and we really see the cattle comfort index climb very rapidly in those kind of scenarios. If we go and look out in the panhandle, we see numbers down closer to 100. Typically, they have more wind out there, and they also have lower humidities, which really helps them out. And that's where a lot of our feedlots are located. Looking at the heat and cold stress categories, one of the things that we did, and we talked to Dr. Mader about this, and I worked with Chris Richards at OSU through the Animal Science Department. But one of the things that Chris Richards looked at was that the publication that Terry Mader and others had put out had about 10 different categories in it. So one of the things that we did is to put this cattle comfort online was we really chopped those down into 2 heat categories and 2 cold categories around that comfortable category. So you can see comfortable, we're at 15 to 85 degrees. That seems like an incredible range. But again, we're looking at, as we get into some of those colder temperatures, we're hoping that the animal has developed a little bit of a hair coat to it. You can see the cold caution that we get into and the cold danger. Same thing when we get into the heat. We're anticipating that the animal has lost some of that hair and will be able to tolerate that higher range. So that's one of the things this model does not take into account is hair coat. So that's one of the things that would be good to add to this somewhere down the road as more research comes about. One of the things that we did with the cattle comfort model was that we put in a 10-day past index or time series graph, and then we went forward with 3.5 days of forecast. So we used the National Weather Service forecast to go ahead. And then we're using, of course, the Mesonet data to look behind. And we looked at some maps where we looked statewide. Well, now this is for a single site. This happens to be for our net, which would be out in along the Texas-Oklahoma border. And you can see that on November 20th at 2 p.m., we had a cattle comfort index of 64 degrees. You can see the air temperature was close to 70. So we had a little bit of wind out there, which brought that cattle comfort index down below the air temperature. And then on November 21st, the very next morning, the cattle are dealing with 7.2 on the cattle comfort index with an air temperature at 29 degrees. This would be a forecasted look ahead. So what a producer could do is see that they're in a situation the day before with some fairly warm conditions for a November, and then they're looking at something more normal for November, but certainly on the low side. And it would be a good time to really monitor younger animals, older animals, any animals that look like they were might have some health problems due to those stresses. And this is jumping, I know, so we've looked at the 10-day and forecast map in a winter setting. This is jumping to a summer setting. And what we're really looking at in a summer setting is, do we have periods of recovery? So this is looking at a July time period, and you can see that in there on the night of July 3rd and July 4th, we had pretty good drops below 75 degrees, even though on July 3rd the temperature had gone up to close to 100 in terms of the cattle comfort index. The air temperature is the red line, so that was lower for that day. But you can see how we got into a situation where the cattle comfort index began to climb after July 4th. And what we're really concerned about are those night times where the index is not dropping below that 75 mark. And that's a concern. A bigger concern is when it will not drop below 80. And when we begin to get successive days of heating and warm nights or almost hot nights, and that continues for a couple days, the animal does not have a chance to recover. So that's the other thing about this time series graph, that folks can look at it and see the accumulation of stress, both in a cold setting, but also in a warm setting. So now we're going to take a look at that data that was, we can view it as a graph, but we can also view it as a table. And so one of the things I wanted to do was kind of drop into these corrections for humidity and wind and sunlight and see how they impact things. So here's a situation where the air temperature is 18.9 degrees Fahrenheit, and we can see how the cattle comfort is way down at 2.1. We come across and look at a high humidity, almost a 13-mile-an-hour wind speed, and the sun is coming up, but it's still pretty low in the sky. And as we go across, we look at these corrections, and we see a 3.8 lowering from the air temperature for humidity. We see a 12.6 degree drop from the wind speed, and from the sun we see a negative 0.4. So as we move ahead and look just a little bit later, about 2 hours later, we see that the cattle comfort index is now at 20. The temperature has gone up about 10 degrees, but the cattle comfort index has gone up 18. And as we go across, we can see that the wind speed's actually picked up, but our relative humidity has dropped, and we've got a pretty good increase in sunlight. So our humidity correction has come down, not quite as negative. Our wind speed is fairly similar, but now we've gone from a negative on the sunlight correction to a positive of 6. So that's how these things kind of play out with each other on a winter or a cold type situation. If we take a look at a heat situation, and I'm going to move that box over to make sure your screen is set and you can see things. But if we take a look, these are two situations across the state. One is looking on the east side of the state, which typically has lower temperatures, higher humidities, lower wind speeds. Out in the western side of the state, and these are on that map with the red circles. Then on the western side of the state, typically we have higher air temps, but we have much lower humidities. We typically have higher wind speeds out in that western side. So if we take a look to the west, starting out there on this day, we had air temperatures at 92, and you can see the heat warning was at 100 in the top, and then an hour later we're at 105, and that's in that yellow box. If we go over to the wind correction, we start, why did this jump 5 degrees? We can see how that wind began to tail off, even though the sunlight actually climbed a bit for us. Looking down at our other example over in the east, we can see a heat warning of 93, and you can see the air temp at 82, and then we see an hour later a little bit of a temperature increase, but now all of a sudden we're 6 degrees warmer for the cattle comfort index. And again, going over and looking at our humidities, that didn't change much. We look at the winds and we can see that wind dropped off, and we lost about 3 degrees from that wind. So when that wind drops off, the humidities go up, we can see a big jump. And you'll note down there on that heat warning, that 99.7 on the cattle comfort advisor, that's with an 83 degree temp, and you look up above, you see that 100.8, which is, they're very similar, about a degree difference, and yet the air temperature is at 92, so almost 9 degrees more. When we start looking at cattle comfort index, why do we need that? I mean, we've got apparent temperatures, heat index. Here's an example in the cold setting where this apparent temperature, this would be using the human wind chill. That's the latest one from the National Weather Service. And you can see on this January day we had 57s down in the southeast in our top map, and as we got out into the panhandle we dropped down to 6. Again, this was a cold front that was coming through with quite a bit of wind behind it. If we look at the lower map, that's the cattle comfort index, and we can see that the numbers are more similar in the southeast to the human index, but as we move across the state, they drop down into the single digits faster, and then we actually drop into the negative range as we move on into the panhandle, getting to that -5, where for the apparent temperature we were at 6. And then looking at apparent temperature, an example for the heat, the top map would be the heat index, the human heat index that's currently being used, and then below that would be the cattle comfort index. And again, you can see that as we move into the cattle comfort index, we have higher heat indices, which is really indicative of the fact that cattle do not dissipate heat as well as humans. So we really do need that unique aspect to try and monitor what's going on with them. Another tool that we have for producers is we do have a past 45-day graph. That shows data in 2-hour intervals. There's no forecast in it, and it, like the other graph, is available in both graph or table view. So this is just an example of that graph, and this would be a summer example that we're looking at. This is for Norman. And if we look over into the July time frame, we can see how we got day after day of above 100-degree cattle comfort index values, and down below we had a lot of days at 75. So this would be definitely a period of concern for a producer to really pay attention to how the animals are responding. And that's one of the things that I really try and encourage folks to do, is observe their cattle and then go back and see what those numbers are in relation to the cattle that they have, both for breed, for health, for age, all of those factors. So the animals will respond differently at different levels. And you can also get an idea, you know, when do certain animals go into water? When do other ones hang back? And shade is sufficient for them. So you can actually begin, if the producer has the ability to monitor some of the individual cattle to see really what some of those unique differences are. When do they lay down? When do they get up? What kind of behavior fits in with the numbers that they see? And we're really hoping to see cattle in a situation where they're out grazing, they're gaining well, they're healthy, and do really, really well for us. I did not want to spend a lot of time today on dealing with heat stress or cold stress. So one of the things you might do is do a search for heat stress. There are lots of university publications out there. There's also a lot of trade publications. This was a good one that I ran into, printed in May of 2014, the Angus Journal. Casey Brown, the associate editor, went through and interviewed a number of specialists and then put that into a single article. On cold temperature management, this was one of the better ones that I ran into. This is out of North Dakota State University on winter management. And they do a really good job of going through and talking about winter conditions and winds and how to help the animals deal with those kind of situations as well as feed. And just for those folks who might not be familiar with the Great Plains Grazing Cap, these are the partner organizations that are working on that project that this webinar is a part of. And of course, this is our project funding for that. One other thing, I do put out a blog, and that's at agblog.mesonet.org. And I go through different bits of information on our models, weather, climate. This happened to be an article on our new wet bulb globe temperature, which really is similar to the Cattle Comfort Advisor in terms of the weather variables and what it advises people to do. So that's all I had, Amber. I can turn it back to you, and any questions that folks might have, I'd be happy to answer those.